The basic material of the PCP version is called the substrate, also known as the copper-clad plate. The components will generate heat when working, so the material of the PCP board must have the characteristics of heat resistance. Even if there is a fire, it must have the characteristics of self-extinguishing. This degree of fire resistance can be divided into grades FR1 to FR5, of which the most commonly used grade F are for epoxy waveform buff. It's split out of this sandwich structure, the upper and lower copper foil. The middle is a semi-cured sheet, of which the semi-cured sheet is commonly known as the connection sheet. It is the Bossini cloth through the deltoid muscle drying to be connection. That is, the semi-cured sheet is in a dissolvable state and will be used to directly press the copper-clad sheet. When choosing a copper-clad plate of different materials, just like when we choose a mobile phone, we will look at the running memory, flash memory, CPU speed, etc. And the parameters of the copper-clad plate are the glass transition temperature Tg, dielectric constant, and thermal expansion coefficient. First of all, the Tg value of the glass transition temperature can be commonly understood as the temperature resistance level. At present, the ordinary FR4 version is generally 140 degrees. If the user needs will exceed this range, the Tg value can be increased to about 160 to 100 degrees by optimizing the numerical value, formula, and other programs. Of course, the cost will increase accordingly. The higher the product of the next defining constant, the more dense the lines on the PCP board. When the transmission signal frequency is high, crosstalk is easy to occur between the lines, affecting the quality of signal transmission. So the choice of the copper-clad plate, with the lower the electrical constant corresponds to the transmission of higher signal effect, is better. The coefficient of thermal expansion is also a very important indicator. The larger the area of the PCP version, the easier it is to thermal expansion and deformation in the subsequent SMT high-temperature links. The thermal expansion deformation can be solved by modifying the numerical value in the copper-clad plate or by reducing the content proportion of the numerical value. It should be noted that doing so will reduce the resistance source performance and chemical properties of the copper plate. In addition to the commonly used FR4 material, there are other different materials. According to the reinforcement material classification, there are paper substrates, composite substrates, metals, ceramics, etc. According to the numerical distinction, there are decentralization values, sentence values, and so on. The above is all about the basic materials of the PCB plate and the copper-clad plate.